In this video, we will learn how to solve for the focal length, find for the numerical values of the coordinates of the vertex of a parabola at h, k. Use focal length, h, and k to determine the coordinates of the focus and endpoints of latus rectum and equations of the axis of symmetry and directrix. And graph a parabola with vertex at the origin and h, k. Let's graph a parabola with vertex at the origin or 0, 0. This example says we sketch the graph of the parabola with vertex at the origin and represented by the standard equation y squared equals negative 12x. To sketch the graph of a parabola, we need to determine the coordinates of its focus and endpoints of the latus rectum. We also need to determine the equations that describe the graph of its directrix and its axis of symmetry. They are both represented by a line. This table summarizes the formulas we need. Here are the formulas for a parabola that opens to the right with the standard equation y squared equals 4cx. These are the formulas we need to sketch a parabola that opens to the left and represented by the standard equation y squared equals negative 4cx. In the third row are the formulas for parabola that opens upward with the standard equation x squared equals 4cy. And in the last row are the formulas for parabola that opens downward and represented by x squared equals negative 4cy standard equation. If you peruse the formulas, you will know that most of the coordinates require the numerical value of the focal length denoted by c. Let's now graph the parabola with vertex at the origin and described by the standard equation y squared equals negative 12x. The first and very important step is to identify its type using its standard form. I said very important because if you incorrectly identify its type, the next procedures will be wrong. We will carefully analyze the standard equation of our parabola to identify its type or the image of its graph. Examine the left side and observe the sign of the coefficient in the right side. Since y squared equals negative 12x corresponds to y squared equals negative 4cx, we are sure that the parabola with vertex at the origin opens to the left. The second step is to select the formulas to be used from the formula table. In this step, You will use the type of the parabola and standard equation to correctly and carefully select the formulas to be used. Most of my former students failed to correctly identify the type of the parabola using its standard equation, which led them to the wrong formulas, solutions, and graph. So, you need to be 100% sure about its type before you proceed to computations. Another common mistake of them was they often used the incorrect formulas from the table. I advise you to have a second or third glance at the formula table before you proceed with computations. You don't have to memorize each formula. Just devise a strategy you can use to easily recall each. Now, since the given standard equation y squared equals negative 12x corresponds to y squared equals negative 4cx, and it is a parabola that opens to the left, we will use the formulas in the second row. So that you won't get confused or distracted by other formulas, I suggest you cover those formulas we don't need for y squared equals negative 12x. In step number 3, we will use the formulas to identify the parts of the parabola we will need in sketching. Since our parabola has vertex at the origin, its coordinates are 0, 0. We will find the coordinates of the focus using negative c, 0. The first endpoint of our latus rectum can be obtained using the formula negative c, 2c, while negative c, negative 2c for the second endpoint. Since our parabola opens to the left and has vertex at the origin, its axis of symmetry is the x-axis. Finally, we will obtain the equation of the parabola's directrix using the formula x equals c. You will observe by now that we need the focal length to determine the coordinates of some parts of our parabola. We will solve for the focal length in step number 4. To solve for the focal length, we will go back to our standard equation. Maybe you already have an idea where we will get the focal length represented by small letter c. We can get it from negative 4c. It corresponds to negative 12 in our given. Therefore, we will solve for c using the equation negative 4c equals negative 12. We need to isolate c in the left side of our equation, hence, we need to divide both sides by negative 4. Negative 4 divided by negative 4 is c. Negative 12 divided by negative 4 is positive 3. Therefore, our focal length is 3. Now that we have our focal length, we will substitute its numerical value to the formula for focus to get its coordinates. Therefore, our focus is at negative 3, 0 of the Cartesian coordinate plane. Let's now find the coordinates of the endpoint number 1 of our latus rectum. We will substitute 3 to negative c and 2c. We will have negative 1 multiplied by 3, 2 multiplied by 3. Negative 1 multiplied by 3 is negative 3. 2 multiplied by 3 is positive 6. We will also substitute 3 to the c's in the formula for the coordinates of endpoint number 2 of the latus rectum. Let's simplify negative 1 multiplied by 3 and negative 2 multiplied by 3. Therefore, e sub 2 is at negative 3, negative 6. We already know that the axis of symmetry of y squared equals negative 12x is x-axis. To find for the line that describes our directrix, we will substitute our computed focal length to the equation. Therefore, the equation of our directrix is x equals 3. The last step is to sketch the graph of our parabola y squared equals negative 12x by plotting its vertex, focus, endpoints of the latus rectum, and graphing its axis of symmetry and its directrix. Afterwards, we should have a parabola that opens to the left. You may also connect endpoint 1 to endpoint 2 to show the latus rectum of the parabola. This time, let's learn to graph a parabola where its vertex is no longer at the origin. The vertex h, k denotes that the graph of the parabola can be seen somewhere around the Cartesian coordinate plane except at the origin. Let's sketch the graph of the parabola with vertex at h, k and represented by the standard equation quantity x minus 2 squared equals 12 multiplied by the quantity y minus 1. Just to let you know, there are some problems involving sketching a parabola where you need to first convert its general equation to its standard form. If you are not yet sure how to do it, you can check my other SEEKnaYan video that teaches the conversion of the general equation of a parabola with vertex at h, k to its standard form. Since the first formula table I showed you is just for the parabola with vertex at the origin, we will have a separate formula table for parabola with vertex at h, k. Take note, we will also use this formula table for parabola where its vertex is at the x-axis or at the y-axis. The formulas in the first row are used to graph the parabola that opens to the right, while the formulas in the second row are for parabola that opens to the left. The formula to sketch a parabola that opens upward are in the third row. Finally, you can access the formulas to be used to graph a parabola that opens downward in the last row. Similar to our previous example, identifying the type of the parabola is the first step to sketch its graph. We will employ the same strategy to identify the type of the parabola quantity x minus 2 squared equals 12 multiplied by y minus 1. Based upon the variables and exponent in the left side and the right side, the standard equation of this parabola corresponds to the standard equation of a parabola that opens upward with vertex at h, k. Now, we will use its type and standard equation to select the formulas to be used from the formula table. Since our parabola opens upward, we will use the formulas in the third row to sketch its graph. You may observe the presence, addition, and subtraction of the numerical values of h and k to each formula tell us that the vertex and the position of the parabola is no longer at the origin. Since each formula requires the numerical values of h and k, in step 3, we will locate the coordinates of its vertex. Let's start with h. Looking at the standard equation, we know that negative h corresponds to negative 2. Therefore, we have negative h equals negative 2. We will divide both sides of the equation by negative 1 to isolate h. Negative h divided by negative 1 is positive h. Negative 2 divided by negative 1 is positive 2. To find k, we will let negative k equals negative 1. Now, let's divide both sides of the equation by negative 1. Negative k divided by negative 1 equals negative 1 divided by negative 1 is k equals 1. Now, we will use the formula h, k plus c to solve for the coordinates of the focus. However, the formula requires the focal length of our parabola. To solve for the focal length, we will do the same procedure in the first example. We let 4c equals 12. Now, we will divide both sides of the equation by 4 to isolate c in the left side. 4c divided by 4 is c. Then, 12 divided by 4 is 3. The focal length is 3. Now that we have the focal length, h and k, we will substitute their numerical values to the formula for focus to determine its coordinates. We have 2, 1 plus 3. Simplifying it, 1 plus 3 is 4. Therefore, the focus is at 2, 4. Now, let's determine the coordinates of the first endpoint of the latus rectum using the formula h plus 2c for its x-ordinate and k plus c for its y-ordinate, and the coordinates of the second endpoint using the formula h minus 2c, k plus c. Now, let's plug in 2 to h, 3 to c, and 1 to k. We have 2 plus 2 multiplied by 3, 1 plus 3. Simplifying it, we have 2 plus 6, 1 plus 3. The sum of 2 and 6 and 1 and 3 are 8 and 4. Therefore, E sub 1 is at 8, 4. For second endpoint, we will replace h by 2, c by 3, and k by 1. We have 2 minus 2 multiplied by 3, 1 plus 3. 2 multiplied by 3 is 6. Now, 2 minus 6, 1 plus 3 is negative 4, 4. So, E sub 2 is at negative 4, 4. In step 5, we will determine the equations of lines that describe our axis of symmetry and directrix. We need the numerical value of h for axis of symmetry. We know that h is 2. Therefore, the equation of our axis of symmetry is x equals 2. We need k and c to solve for the equation of our directrix. We know that k is 1 and c is 3. Substituting these values to the equation, we have y equals 1 minus 3. Now, 1 minus 3 is negative 2. Therefore, The equation of the directrix is y equals -2. We can now sketch the graph of the parabola that opens upward. Quantity x minus 2 squared equals 12 multiplied by quantity y minus 1 using the coordinates of its vertex, focus, and endpoints of its latus rectum. Also, the equations of its axis of symmetry and directrix. It's your turn to graph a parabola.